I'm Udayan, co-founder and chief product officer of Clairco. Clairco helps commercial buildings with solving two large problems. Firstly, reducing the energy consumption of the air conditioner using IoT and AI. And secondly, improving the indoor air quality of the buildings for better occupant wellness using nanotechnology. Clairco was started by Ayush and me in 2018. We are both school friends and we have around 10 years of experience in the startup industry. Currently, we are at a scale of 15 million square feet across India, and we are saving around 22,500 tons of CO2 emissions annually through our energy saving offering. Both Ayush and me are Forbes 30 under 30 Asia in the year 2020, and we have won several other awards in India for our innovation and for our impact. Our clients are both real estate developers like MR, Capital Land, Brigade Group, etc., and also end tenants like WeWork, Samsung, PepsiCo, etc., across all major cities in India. And we are also launching in the UAE in the next month. So in the industry, let's look at what are the USPs of Clearco. So in the industry, conventionally, if you look at for both energy saving and air quality management, the initial upfront capital expenditure for clients is extremely high, and still there is no guarantee of performance, which is means that there is low accountability. And because of high capital expenditure, the ROIs are almost more than 3 years, and in some cases 5 6 years. Clearco is solving all the three problems using firstly our unique business model, which is zero capex, clean air, and energy efficiency as a service, which means that the clients do not have to pay upfront for any of the hardware that we're installing, and we only get paid from through the savings that we deliver. So, which means that there is 100% accountability from day one because we only get paid when there is a saving. And secondly, for the clients, it's an immediate ROI because we're sharing the energy savings with them. So from day one, they are able to save their overall expenditure while also reducing their carbon emissions. So let's look at how the HVAC system or the air conditioning system of a building works. In this diagram, we can see that there is a chiller in the basement. This chiller is responsible for sending the chill water to each floor. In each floor, there is something called a AHU or a air handling unit, which is responsible for supplying the air in that particular zone. Here we can see that the chiller is sending the data, sending the chill water at 6 degrees, and it is coming back after cooling the air at 12 degrees. This energy required, and then again it cools it back to 6 degrees. So energy required to cool it from 12 degrees to 6 degrees is what consumes the energy consumption of the air conditioner. And this is almost 60 to 70% of a building's overall energy bill. So which means that almost 60% of the energy is being consumed by the HVAC system. And that is what Clearco is helping in optimizing, because it has been documented across multiple studies that almost 30 to 40% of the HVAC energy consumption is wasted due to lack of optimization. So let's look at how our system works. So in this diagram, we can see on the left hand side, there is a typical zone where people are working. And in each zone, we install multiple 3D thermal imaging based occupancy sensors as well as temperature and humidity sensors. These sensors detect the temperature and occupancy of each virtual corner, and we are able to control the HVAC based on this feedback. So our system, our AI engine determines what should be the ideal zone temperature of this particular zone based on multiple data parameters, which are the indoor temperature, indoor occupancy, and outdoor temperature and other weather conditions. And this is controlled by controlling the set temperature on the thermostat, as you can see in this diagram. So our system automatically sets the temperature, and this controls the overall chill water flow in the AHU through by controlling the actuator valve. On top of it, we also retrofit the existing air handling units with our patented filtration system called Nano Clear filters, which takes care of all kinds of airborne pathogens and organic gases like hydrocarbon, formaldehyde, benzene, toluene, and also NOx and SOx. And also, we install another filter on top of it, which is your high grade efficiency dust filters for your dust particles in the air. So by doing this, we are able to improve the indoor air quality of the building while saving almost 20 to 30% of the air conditioner energy, which translates into around 15 to 20% of overall building energy consumption savings. So that is where we are making an impact on the, because the energy consumption reduces, so the carbon emissions also reduces. And this is a simple flow chart to explain the same. So we install multiple these sensors as I spoke about, and this goes to the gateway which communicates with the AI engine, and the AI engine again sends back the command into the gateway, which in turn controls the switch, The switch is connected to the thermostat where we automatically change the temperature. And this based on the temperature on the thermostat, the actuator valve of the building of the AHU is controlled, which results in energy savings, which is also called BTU savings, which is British Thermal Unit. And this is a sample of the 3D thermal image that I was talking about. Just to clarify, this is not a camera, this is a sensor. So our sensors are extremely much more affordable than cameras, and there are no privacy issues with them. And this 3D thermal image helps us in understanding the zone, latent heat of the zone, and ultimately determine the zone temperature. This is how the dashboard looks like when a client logs in on the landing page. So here they can, on a real-time basis, see the actual BTU consumption on a real-time basis of every hour. They can also see a cumulative BTU consumption or the energy consumption. They can also see whether VR optimization status is on or off. So they can switch off the optimization status just to check whether our system is delivering savings or not. And they can also see on a real time basis how much exactly savings in terms of monetary terms they have made in each day, week, and month. And the a percentage of these savings is what Careco charges. Similarly, if we go on the floor level data, they can see in each AHU what is happening, and at each BTU meter level what is happening. BTU meter is nothing but an energy meter which uh, calculates how much energy the system is, how much cooling energy the system is consuming. So once they go into the AHU, they can see the set temperature of the thermostat. They can see the return temperature, which is basically an aggregate temperature of the zone, and they can also see the chilled water position. So this green graph, which shows the chilled water position, is what determines how much chilled water will be consumed. So this is what we automatically modulate to deliver energy savings. They can also see what is the current temperature in the zone and the humidity in the zone. Similarly, if they go into the BTU readings, they can see at what temperature the chilled water is going in the AHU, at what temperature it is coming out, and the difference between this in temperature and out temperature is what is called the delta T. So this also helps us in understanding whether the chiller at the basement of the terrace is functioning at this maximum efficiency or not. Similarly, they can also see what is the water flow rate of the chill water, and also the overall energy consumption of the building. So all these data points go into our algorithm and help in delivery energy savings. So a couple of case studies. So one case study in Hyderabad was a building which already had done a lot of interventions for energy consumption. So they had automatic temperature control in place, and they also had a building management system in place. But still the savings were not sufficient because they were only controlling the temperature automatically based on very less data. What Clearcode does, we integrate a lot of hyperlocal sensor data into our AI engine and further help in optimizing the energy consumption. The challenge was to improve the savings of this particular building. So in March 2023, we installed our system here, and we were able to achieve a very impressive 30% reduction in overall cooling energy or the air conditioner energy. And now we are scaling up in this building as we speak. Similarly, another case study of Bangalore in India, where there was no BMS, no building management system, and the temperature control was manual, and the HVAC system was extremely old. It was like more than 10, 12 years old, and the client did not want to spend on upgrading the HVAC. They wanted to see with the existing HVAC how much optimization can happen. So in last year, October 2022, we again made our installation, and we were able to achieve almost 32% reduction in overall air conditioner system with even with the older HVAC. Similarly, more case studies in other cities in India. Like I said, we are present in all major cities in India. Our air quality monitors, like I mentioned, we are also into air quality management. So we measure air quality parameters like particulate matter 2.5, PM10, CO2, TVOCs, and temperature and humidity. And these monitors are placed all across the building to measure the real-time air quality. And like I mentioned, that we install high efficiency dust filters. So these dust filters are actually consumable, so which means that over a period of 12 to 15 months, they need to be replaced. So worldwide, what happens is all these filters which needs to be replaced, the older filters get discarded into landfills, and it creates a waste management problem. So what we do here is that we, instead of throwing them away, we upcycle them into useful materials like uh, coasters and tiles. so that the overall waste generation of the building is reduced, and these products are also carbon negative and it will help in reduction in the carbon emissions of the building. And we can imagine the scale of this impact. Globally, there is almost 45 billion square feet of grade A and grade B real estate, and all of them are just throwing away the filters every year. So how much waste, a lot of waste can be saved, a lot of carbon emissions can be saved with this initiative. Thank you so much.